Jai Hind. I am Madhup Agrawal, and today's our topic is quicksort algorithm. So this is a very important topic of data structure. We will understand it in algo form, in programming form, and with the help of examples. So let's begin. Now, what is quicksort? Quicksort is a sorting technique. This is a sorting technique. There are many sorting techniques, in which one of the quicksort, and this is most important sorting technique, and this is very fast technique, and by which divide and conquer approach. This works on divide and conquer approach. And we also know what is sorting. Sorting is arranging data in ascending or descending order. Now, what is divide and conquer? In this approach, we first pick the pivot element. In this, we first pick the pivot element, and after that partition or rearrange the array into two subarrays such that each element in the left subarray is less than or equal to the pivot element, and each element in the right subarray is the greater than pivot element. Let us see an example. And what is the conquer? Means recursively sort two subarray with the quicksort approach. So just take an example. If we choose a pivot element, we can choose pivot element first, last, or any other. So position the pivot element at its proper position. Let's pivot element get position here, and in this part all the element will be less than this pivot element, means right subpart or right subarray contain the lesser element than the pivot element, and in the right subarray greater element than the pivot element. So the whole array is divided into two subarray, and pivot element gets its fixed position. So the process fundamental to the quicksort algo is the partition. So the way partition works by the first selecting the pivot element. Select the pivot element, and there are many options to select the pivot element. We choose a first element as a pivot. We can choose the last element as pivot, any random element as a pivot, or middle element as a pivot element. So we will see the example with the help of last element as a pivot element. So here as example, let us select the last element 3 as our pivot element. This is our element which is stored in the array. We choose the last element. We choose the last element as the pivot element, and we position it at the right place with some process. How to? We will create two sublists. The left list contain the value lesser than the pivot element. Here, after the process, the pivot element which is selected as get its proper place, and the left subarray contain lesser value than this pivot element, means -3, 2, -6, and 1, which is less than the 3, and the right subarray contains the greater element, that is 8, 5, 9, and 6, which is greater than 3. So pivot element fixed at its proper place, and the same process recursively applied on these two parts, first part and second part, second division and first division both. So now in this part, in the first part, in the left part, same process repeated, means choose the last element as pivot and position it at its proper position, just at its proper position, so that lesser element than 1 comes in the first part, that is -3 and -6, and greater element in second part, that is 2. Same process repeated here for the second part, that is 8, 5, 9 and 6. We choose the 6 as pivot element, last element, and position it at its proper place such that in the first part lesser element than 6 and in the second part, right part, greater element, that is 9 and 8 then 6. Now this repeated recursively. In this part also choose the last element as pivot element and then divide, and in this part we also choose the 8 as last element pivot and further divide, and in this part let us minus 6 come its proper position and lesser element than minus 6. No other element less than the minus 6. So no partition here. Only the right partition contain only one element. So there is no need to further divide. And in the second part, 8 is come at its proper position. No first part here, less than 8, there is no element. Greater element than 8, that is 9, comes in the second part. So there is no further division required. So finally our data in this form minus 6, minus 3, 1, 2, 3, 5, 6, 8 and 9, which is in ascending order, means in the sorted fashion. See again. This was our original array. 3 comes in proper position, then 2 further division. Next one choose one as a pivot and pivot come at its proper position, and then 2 parts, again 2 parts, one element here further division 6, and here less than 6, 5 and 9 and 8 greater than 6, and further division of this portion, that is 8 and 9. So in the same array at the same place our sorting done. So this is a type of in place sorting. We know in place sorting means at the same place we sort the data, no extra space is required. So now we can do the same here with another example. Just see how to do. Then we will see the algo, then we will see the program. First we will see how to do the whole process. So first just guess, this is our data 80, 50, 30, 90, 20, 10, 40 and 70. Now sort this. So this position, starting position, means this is starting position, this is last position of the array. So we choose the last position element. This is indicated by P. First position indicated by P, last position indicated by R. We will choose the last position element as pivot element. So we will choose here, which is 70. AR, we put the AR data, means last element, into the variable X. So here this is 70. This is, just wait. Now this is 70. Okay, last element, we will put last element in the variable X. Now what is I? I is 1 less than the starting element. Starting index is P. This is P for whole array and this is are for this array. P and R location. P starting location, R last location. Now our array is this whole one. So P is the 0 and R is the 7. Now I is P minus 1. P minus 1 means 0 minus 1 equal minus 1. This is 1 less than the, and J. J is the loop. Start from P to R minus 1. Means J will start from 0 to the 6. Now at the starting point, J is the 0. J is the 0. Now what to do? Just see the element at the position indicated by J is less than or greater than the element indicated by X. If the element is greater, then proceed further element, increment the J. If this element indicated by J is less than, then what to do? Just two step, just increment the I. Listen, increment the I, then swap the element position indicated by I and J. Swap the element indicated by I and J. So first here, look, this is 70. Now start indicated J is 0. Now element position at J is 80. Now 80 is greater than 70. What to do? Simply increment the J. Means now J become 1. J become 1. Now compare the element 70 and element indicated by this one. This is 50 is less than 70. Then what to do? Just increment the I. Increment the I means increment the I minus 1 plus 1, that is 0, and swap the element at the position 0 and 1. Means element indicated by I and element indicated by J. Now swap the element 0, means 80 will come here and 50 will come here. Okay. Now next increment the J. Again loop. Now this is 30. This is less than the X element. Then what to do? Just two step, increment the I, then swap the element indicated by I and J. So increment the I means this is 1. Then swap the element positioned by the I and J, that is 1 and 2, indicated by 1 and 2. At the position 1, the 80, at the position 2, 30. So swap it, means here 80 and here 30. Now increment the J. Increment the J means J will 3. Now J is 3. Now check the position element indicated by 3, that is 80, 90. 90 is greater than 70. Then just increment the J. Increment the J. Now J become 4. Now 20. Element indicated by 4, that is 20. 20 is less than the 70. Then what to do? Two step. Again increment the I. Increment the I means 2, and swap the element indicated by I and J, means second position element and fourth index element. Second index element and fourth index element. Second index element this, and fourth element fourth index element is 20. So 20 will come here and 80 will come here. Now increment this particular J, that is 5. Now at the position indicated by 5, fifth index, that is 10, which is less than the 70. What to do? Two step again, that is increment the I, means 3, and swap the position indicated by I and J, that is 3 and 5. At the position 3, that is 90, and 5, that is 10. So 90 will come here. Swap means 10 will come here and 90 will come here. Okay. Now increment the J. that is 6. Indicated by 6 is 40. 40 is less than the 70. So what to do? Increment the I, means 4, and swap the element indicated by I and J, that is 4th and 6th index element. 4th index element is 80 and 6th element 40. Now 40 will come here, 40 will come here, and 80 element is 80. 80 will come here. Now J moves from P to R minus 1. R minus 1 means 6. Reach at its maximum position, that is 6. So come outside the loop. Now after coming from the loop, what to do? Just swap. One swap is required. Just swap the element indicated by I plus 1. I plus 1 with the element indicated by R position, means pivot element. Now we are moving the pivot element at its proper position. So I plus 1 indication, I is 4, I plus 1 is 5, means at the 5th index location, just put the AR index element. That means 70 will come here and 90 will come here. Now at this point 70 at its proper position, that was the pivot element. Now 70 is here. In this part, the element is, this is 50, this is 30, this is 20, this is 10, this is 40, this is 70, this is 80, and this is 90. Just see, in this pass, in the first pass, all the element less than the 70 pivot at its proper position, and in the left portion 50, 30, 20, 10 and 40 is less than 70, and 80 and 90 are greater than the 70. So we will break our original array into two sub array, two first left array and second right sub array. So 70 at its proper location. Now repeat the process for first and second half. Now see here, at this point, repeat the process for first half, means from here to here, from 50 to 40. Now for this P is 0, and for this R is 4, last element at 4th index. Okay, so for this portion, now repeat the process. For this portion, now X equal AR. R is 4, so AR is 40. Now this is 40. Again repeat the process. And I, position of I is P minus 1. P is 0, so P minus 1 is 0 minus 1, that is minus 1. And our loop will repeat from P to R minus 1. R is 4, so R minus 1, 3. Start from 0 up to 3. So at the first point, J is 0. Now repeat the same process we have done before. Now 40, 50 indicated by J position is greater than this particular 40 element. So what to do? Just increment the J, that is 1. Now 1 at the 1 position, 30 is less than the 40. Then what to do? Just 2 step again, increment the I, minus 1, 0, and swap the element present at the location I and J, that is 0 and 1. At the 0 50 and 1 is 30. So 30 will come here and 50 will come here, no problem. Then repeat the process. Now increment the j. Now this is 2, and at the second index location, there is 20. 20 is less than the 40. Then what to do? Simply increment the I and swap the element at the position indicated by I and j, that is 1 and 2. Means 20 will come here and 50 will come here. Now simply increment the value of j. Now j will 3. At the third index location, this is 10 less than 40. What to do? Increment the I, that is 2, and swap the element at index 2 and 3. 2 and 3 means 10 will come here and 50 will come here. Now what to do? Increment required? No. R minus 1. Last index was 4 and 4 minus 1 3. So we have reached its maximum limit. Now come outside the loop, and we have done. Now move the pivot element, that is 40 at its proper position. How to do it? Just I plus 1 location. Swap I plus 1 location means I is 2 means third location index. Third here. I plus 1 location, third location. Swap with this R location, that is fourth location, means 40 will come here and 50 will come here. At this point, the pivot element that was 40 come its proper position. Now 40 is fixed. Now our two subarray, that is 30, 20, 10. Now 40 is fixed and this 50. Now two subparts 30, 20, 10, and second part only element 50. So again repeat this process for this subarray. Now here P is 0 and R is 2. So now X equal AR means 10. X equal 10. For this subarray, X equal 10. And I equal P minus 1, that is 0 minus 1, that is minus 1. And J start from P to R minus 1. P means this 0, R minus 1 means only one position, 2 times loop will execute, means 0 and for 1, 0 and 1. So for 0, now execute. At the position indicated by J, that is 0, 0 is 30 is greater than 10. Then what to do? Simply increment the J, means J. And at the J position, 20 is also greater than 10. So what to do? Simply stop and come outside the loop. Outside the loop, what to do? At the position I plus 1, means minus 1 plus 1, that is 0. At the position 0, put the AR element. Swap the AR element with this position, means 10 will come here, 30 will come here, and this is now fixed. Pivot gets its proper position. Now only second part is here, 20 and 30. Okay, no first part, only second part, 20 and 30. Now the same process repeated recursively for this portion, for 20 and 30. This portion. For this portion, starting index is 1, last index is 2. So P is now, for this P is 1, R is 2. So at the index AR means this location, that is 30. At AR, element is 30. Now I equal P minus 1. P is 1, so P minus 1 is 0. And this is start from P to R minus 1, means only one time. R is 2 minus 1, only one time will execute. Now check the element at index 1, 20. 20 is less than the 30. Then what to do? Simply increment the I means 1, and swap the element present at the I and j location. I is 1, j is 1. So 1 1 swap its own position, means no changes, 20 will remain here. Come outside the loop, and what to do? At the position I plus 1, put the element AR, means I plus 1 means second position, second index position means this position, put the element AR, means same position, at the same position. No exchange will occur. Now 30 will get its proper position. Now, so 10 fixed, 30 fixed, 40 fixed. Now in the first part only one element is here, so there is no required for division further. Now this is fixed, no need to further division, so this is fixed. Now in the second part of this, only 50 element, only one element, means only one element condition, P and R at the same location. P is 40, starting is 40 and ending is 40, starting is 4 and ending is 4th index. So when P and R lies on the same index, don't divide further. So now this is fixed. Now first portion of the this particular array is sorted, 10, 20, 30, 40 and 50. Come into the second part of the original array, that is 80 and 90. For the 80 and 90, P is, starting position is 66 and end position is 7. Now P is 6 and R is 7. So for this, the X is 90. For this, X is 90. X is 90. And I is P minus 1. P is 6. P minus 1 is 5. And this is P, that is 6. That is 6. So what to do? Just see here, 80 is greater than 90. So what to do? Increment the I, that is 6. Now swap the element at present at the location 6 and 6. No swap will occur. No swap will occur. Now come outside the loop. What to do? Put I plus 1 position element. Swap I plus 1 position element with AR, means I plus 1 means 7. 6 plus 1 7. 7 and 7. No changes will occur. Fix here. Only one element left here, that is 80 in the first part. So P and R lies at the same position. So fix here. Now we can see no further division required, partition required, and now our array is sorted. Array is 10, 20, 30, 40, 50, now 70, 80 and 90. This is our array, 10, 20, 30, 40, 50, 60, 70, 80 and 90 in sorted manner by using the quicksort, and mention last element as a pivot element. So this is the process, hold the process. Now we will see the algorithm. This is the algorithm for quicksort. A is the array, P is the starting index, R is the last index, and we will divide. When division occur? When P is less than the R, then we divide the array, otherwise no need to divide the array. And we will call the partition. We have done the partition as we have seen earlier. Partition, same parameter, A is the array, P is the starting index, R is the last index, and after partitioning, pivot element goes its proper position, that position indicated by Q. Q is the final pivot index. This function will return the final position of the pivot element. We will store it at the Q. And this is the first portion, left portion. Divide the, again apply the quicksort algorithm on the array A, starting with the P and ending with the Q minus 1, because pivot element lies at the Q location. So Q minus 1 location is the last location for the first half, and we will perform the quicksort in the first half, and same quicksort on the second half. Second half start from Q plus 1 position up to R position. Now the main portion is partition. So we have already seen, and here with the help of steps, now what to do? Just choose the last element. We have put the last element indicated by R to the X, and I is the P minus 1, start position minus 1, and loop J from P to R minus 1. And when element indicated by AJ is less than equal to X, then what we have done, increment the I, means I equal I plus 1, and swap the element indicated by I and J location. This is hold the loop up to R minus 1 location, and after coming from this loop, we have swapped the element present at the location I plus 1 and location, last location, that was pivot. Okay, so we have swapped. Now return the pivot comes at position I plus 1, and we have written the I plus 1 location. So this is our algorithm. Now we can convert our algo into the C program, same with the help of syntax, proper syntax of this particular language. C program, this is a Python range of Python program also, and this is partition, and this is driver code our, and this is our this is only Python code. Okay, we have done here. Okay, thank you, thanks a lot.